No ale to je jedno, no, tak, že jsem no, my jedeme dva. Teďka udělali čáru dál, co se kde odskočí. Jako okolo vás a na Slovany, takhle to bylo. No.
No to je vlastně na
No a to ale když jste tam měli KKP a proto.
Právě, já mám představu ty věci, Už ne? Byli to pravým, jestli to ještě 4 roky, se velice omlouvám. Celý ten soubor. Jo, tak ještě kolegové mají nějaký dobrý aplikace, tak já teď moderuju, no. A vaše sekce byla úspěšná? Jo. Potřeba to. Mějte se hezky. No, já to rovnou. Tak dámy a pánové, zdá se, že jsme připraveni a můžeme zahájit.
Well, ladies and gentlemen, it looks like we're all ready and we can start with our last panel discussion. At the end of the previous roundtable discussion, it looks like the streaming stopped working, so we fixed it. It is not that the conference is over. We're still continuing, and we hope that streaming will stay on. So the last panel, it's kind of ungrateful to be the last one on the last panel, but I think that now I understand that the organizers decided that the best speakers and the most important topic should be in the last panel. And it looks like we have still quite a few people in the audience. So thank you for staying with us. So the last table is about modern nuclear technologies, developed technologies. So of course, nuclear applications are always about sophisticated solutions, sophisticated control and security systems. So there is a lot to discuss. So in that context, I always remind the audience about the successes of the former Czechoslovakia. In 1957, we were the 9th country globally which succeeded to have a chain reaction independently started in our research institute in Rzeszów. And then in 1972, we were the 8th country in the world that was able to individually design, manufacture, and start operating a nuclear power plant. So that was a huge achievement as well. So the gentlemen sitting at the discussion table are the successors of those experts that we had back then, but I'm sure that they're just as skilled and inspirational as their forefathers. So let me introduce the panelists, Mr. Karel Stoches from ZAT and Tomáš Záruba from Škoda JS. Tomáš Ondračka from Mifre Energy. Jan Jakubek from Advacam. Miroslav Popovič from SVS PEM. And we have a specialist, Zoltán Takács from MVM EGI, and a Hungarian company. So in the previous panel, we didn't have any presentations, but I think we can make an exception because there's a lot to tell us about your achievements. So maybe I will ask you one by one to present the achievements of your company. So Mr. Stoches from ZAT.
Už to je slyšet. Tak ještě jednou pěkný podvečer. Jsem tady za firmu ZAT.
So good afternoon. I represent a company called ZAT, a joint stock company. We are a world supplier of control systems for nuclear applications, both security system and non-security systems. So our systems and know-how can be found in 1/3 of nuclear power plants in the EU and 10% of nuclear power plants globally. So we deliver solutions for small and medium and large power plants. And you can see the statistics relating to our company: 53 years of experience, 16 solutions or products for nuclear power plants, 49 units in operation at this moment using our solution, a ZAT solution. And we successfully received licenses in 9 countries from 9 nuclear regulators. So that's about it. So beautiful numbers, self-explanatory. Tomáš Záruba from Škoda JS. Just a quick introduction of your company, please.
To jsem já, to není firma. Ne, dobrý večer. Já bych jenom poprosil.
So this is me. This is not the company. But good evening to all of you. My name is Tomáš Záruba. I'm the head of verification and validation in Škoda JS. So even though we're called Škoda Nuclear Engineering, we're also dealing with various control systems, and I'm responsible for that. And next slide, please. So this is about our company. I guess I don't have to introduce our company. We've been active not only on the Czech market, but also abroad for over 6 decades. We have 3 main pillars that we stand on. That is engineering, component manufacturing, and service. So we cover the whole life cycle of nuclear applications and also various fields present at nuclear applications. So, of course, we have a huge project in Mochovce, and construction of their units. We've completed the third unit in Mochovce, and recently they've just finished their general maintenance exercise. And as for manufacturing, I'm mentioning the insides of the Hinkley Point C and Sizewell C nuclear power plants. So we're delivering components for them. And you can see that our company is successful not just on the domestic market, but also abroad. So I am the head of control systems, and we're renewing the control systems in Temelin, the diesel generators, and also various security systems related to that. So that's the introduction of our company. The next one, Tomáš Ondračka from Mifre Energy.
Halo. Tak ještě jednou dobrý podvečer, dámy a pánové. Jmenuji Tomáš Ondračka, já zde zastupuji společnost
Ladies and gentlemen, I represent Mifre Energy,
skupinu Mifre.
Mifre Group, rather. So Mifre Energy delivers a comprehensive solution to nuclear applications, nuclear power plants, and we're active in various areas, but our main focus is in the nuclear. So whatever you need, any solutions relating to radioactivity, radionuclides, and toxic substances, we are involved in that as well. Mifre is also active in waste management and also electricity, high voltage, low voltage, and automation of that. Next slide, just very quickly. The members of the Mifre Group. This is Rizzo. I think it's quite a well-known company which offers consultation and engineering services, especially when it comes to security and reliability of critical assets. They are ISO 19443 certified, so it's well-established company. Another company in our group is M-Shield, which delivers shielding solutions mainly for nuclear power plants, but also for nuclear medicine. We have applications in research and development, X-rays, and so forth. So the M-Shield company manufactures and implements and operates these machines. Via Alta, that's another company in our group. We just renamed that company, even though their activity is the same as in the past. The Mifre Group has been changing so fast that we're not even able to keep up with that pace and update the applications. But Via Alta specializes in research and development in waste management. So we're developing solutions for various types of waste, including radioactive waste. And the next company, another company in our group is PIFA Telecom, which provides solutions for electrical solutions, for electrical technology, high voltage, low voltage. So these are companies that do automation of various units.
Okay, new slide up, please. The new block Slavice Center is an entity that essentially is built near the very vicinity of the nuclear power plant, and provides spaces for laboratories, training spaces, etc. So this is very briefly in a nutshell about Mifre Energy. We are also heavily engaged in international projects, particularly in the Emirates, and we have a supply chain for the nuclear power plant at Varta.
Děkujeme, vidíme, že tady máme v podobě pana Ondračky 7 v jednom, jestli jsem
Okay, so if I've done the right math correctly, there seem to be 7 different companies represented now. Mr. Fodor from Advata, please make a short introduction to your company. Can you hear me? Hello, can you hear me? I'm from Advaka, which is probably the youngest company. We are 13 years old. We are a spin-off of the Institute of Technical and Experimental Physics of the Czech Technical University. And we do special radiation measurement and imaging solutions for the global market. We have a different 20 different sensors on board the International Space Station. We also develop imaging methods for medicine. This is an example of a machine that helps treat patients with brain carcinoma. Our cameras are also used for extending the life of a nuclear power plant in Canada, checking wells and imaging technologies for various other solutions at the nuclear power plant. What is unique about this technology is that it was originally developed for high energy particle physics center in Bern, Switzerland. And the purpose way back then was to see a reasonable particle, and it's a photon counting or particle counting sometimes. The unique thing about it is that if you use it as RTX, then you can use also various color visualizations. So on this 3D document, this one particularly giving you an image of a compound in some hybrid structure. So this is it about us. Thank you very much. I'd like to going back to what you said, CERN, the company. It's great to see that you actually can go that far. Well, we were one of the first spin-offs at the Czech Technical University. When we did so, we weren't quite sure about how to go about it. It was 20 years about. I actually was working for CERN 20 years before I actually funded this spin-off. But we've been around for 13 years, and we have 70 employees, and we supply worldwide. Thank you and congratulations. Mr. Popovic is from SPSFM. Hello, my name is Miroslav Popovic. I represent a small company, SPSFM. We've been around for 30 years, so we are not the new kid on the block. We will be a small company compared to the giant sitting next to me, but still we are very lucky in that in Czech and Slovak republics we have almost 300 partners in various disciplines. Many of them do nuclear industry, in the automotive, etc., etc. And our work is to use our resources to help them digitalize simulations, deal with computation tasks, and deal with their specifics where they are sort of meeting challenges. And we are lucky enough to face various numerous issues, problems. Sometimes it's quite interesting to do so. We are able to interconnect companies who are dealing with specific tasks. You know, there are companies like automotive suppliers who say, we don't have enough jobs, you know, we've lost business. And companies from the military, from the defense industry, for instance, say, we don't have people, we don't have engineers, etc., etc. So this can work together. Similarly, the residual material that IEP actually uses for containers was then used by one particular entity in the military or the defense industry. So it's quite interesting to connect these two sides, demand and supply. I studied Czech Technical University and I had no idea what I would be doing. I was thinking tractors or maybe airplanes. I had no idea. So I started following this advice to do applied mechanics. So I did study applied mechanics, and it's quite interesting because you have all sorts of clients, and if you have any questions, I'll be happy to take them later on. I'm sure there will be questions later on, and I'm glad you mentioned the overlaps between individual disciplines, because we're talking about computational power, computational tasks, and AI, etc. So you develop something in one field and then it gets used in another. And then our colleague Zoltán Takács from MBM.
Good afternoon. It's a great pleasure to be here again. Instead of a general company introduction, I start with a slide introducing the main essence of my presentation. Of course, in few words, I may introduce the company. I joined the company in '86. Company is MBM EGI. EGI is a very long history company. We were founded in 52, and practically we are designers and suppliers of various cooling system types for many power applications, combined cycles, steam plants. We have also reference with nuclear power station. We are acting worldwide. We have a factory also for the heat exchangers that we use in our cooling systems. And this single slide focuses on the key feature of the solution that we recommend you for the near application of Dukovany project. Where instead of all wet cooling system, I mean wet cooling towers, we recommend to use the so-called dry wet cooling solution. In my presentation, I will speak more about it, just summarizing. Approximately 50% of the evaporated water can be saved by this solution. So this is why I put this slide in front of you first. Thank you.
My můžeme pokračovat rovnou tou prezentací, kterou pan Takáč avizoval.
And I suggest that Mr. Takács can actually start with his presentation, so that it's uninterrupted.
Yeah, I can use it. Okay, I can use this microphone. So, sorry, I continue then with my presentation. As I introduced you, a dry wet solution is recommended for this large upcoming project. Please, the next. Here you see a simple sketch showing the cooling, the power cooling possibilities in general. If we focus on the nuclear applications, usually one-through cooling or wet cooling are used. These were in the past practical solutions for power station, for nuclear power station cooling. Besides the wet cooling, we also provide dry cooling systems. As you know, in many countries, water is not available, and unfortunately, due to global warming, less and less water is available also in our regions. Besides the wet cooling and dry cooling, we may consider also combinations from any of these basic solutions. Wet and dry solutions are available as per the project needs. If we consider the water consumption of a power station, there are two extreme situations. Either all dry cooling is used. You see in the diagram on the left-hand side, or the other on the right-hand side is the wet cooling. And this diagram shows how much is the annual water consumption in percentages compared to all wet cooling solutions. For each and every project, considering the project specific conditions, limitations, we may configure a dedicated solution. For example, if we want to save 50% water, then somewhere from the middle of this diagram, we have to select a configuration. What are the key benefits with dry wet cooling? Why should we use dry wet cooling for large nuclear power stations? One is the substantial water consumption reduction. The other one is an environment protection related issue. There are less emissions from the cooling tower. Emissions at the top of the cooling tower, or emissions, for example, in the blowdown water from the cooling system. And by the way, if you use a certain dry portion in these cooling systems, we also have a certain flexibility in the site selection usually. It's not mentioned in this slide. And what is the drawback? Drawback is if there is a certain dry cooling portion, slightly lower power generation is the case when we consider the same heat input from the reactor or from the boiler in another plant. Here you see, as an example, two projects where initially wet cooling towers were used in some of the units. And when the customer, the owner of the plant, wanted to extend the project with new units, they realized that there is no enough water for the new units. So you see at the same site wet cooling towers and dry cooling towers. We provided the dry cooling towers. The bottom photo shows a recent, relatively fresh project for really large coal-fired units. Next one. The dry wet cooling with 50% water saving needs a dedicated configuration. It means that you should consider the water-cooled condenser under the steam turbine, and instead of a simple wet cooling purpose, the dry wet solution has not only wet part, but also dry coolers. The wet part is located inside the cooling tower. That yellow area is showing the wet part, and the dry part is on the circumference of the tower. You see those blue heat exchangers, air coolers, finned tube heat exchangers. And the circularity is that both sections are in the same cooling circuit, and both parts provide cooling during the year. Next one. In these two diagrams, you see on the left-hand side the water consumption comparison. The red part or red area illustrates the all-wet cooling. That is 100%. The blue area represents the dry wet cooling water consumption. On the horizontal axis, you see the ambient air temperatures from minus, say, 15 to plus 40 degrees C. On the right-hand side, you see how much is the generation difference on the steam turbine. So slight reduction is with the dry wet cooling, but not a major reduction. But we save 50% of the water for this application. Not only large power units may be served by our cooling systems. Here in many presentations, also the SMRs were mentioned. The recent SMR developments consider different unit sizes from, say, 50 megawatt to 500 megawatt. Depending on the size of the unit, one may consider natural draft cooling tower, as shown in the previous slide. But for the smaller units, one can use also fan-driven solutions where the air moving is by fans. We have many references, applications in cold climates, for example, in some countries. Next one. And with this technical solution, we have a nuclear power plant reference as well. More than 55 years in operation, still in operation today, installed at the beginning of the 70s in the former Soviet Union, where in an extremely cold area, in a gold mining area, NPPs were installed and our dry cooling towers were applied, still in operation. Here you see also an important project in our life. This is the largest dry-cooled combined cycle power plant in the world. And the operators report mentioned in this slide is that they experienced 99.8% availability in the mentioned year of 2010. Here, really the highest technology level was provided for all components in the power station. The next slide introduces the customer satisfaction. All these photos were taken in one country, in Turkey, as an example, because also from other countries we can show similar pages. So for Turkey, we provided several projects during the past decades. Next. One of them is a project. I started my career in '86, spent 2 years in that project. A combined cycle plant was installed with 2 cooling towers, but after more than 25 years, 2 new units were installed. The old blocks units were demolished, but our dry cooling towers were connected to the 2 very new modern combined cycle units. Siemens provided that. Next one. The last slide is our Hungarian Matra power station. There are many innovations. There are several units served by wet cooling and dry cooling. Dry cooling towers are applied in 4 units. there were many innovations. This slide simply represents again the long operational lifetime, because the first units were installed at the end of the 60s, the last units during the first half of the 70s, and the plant is still in operation. Our mother company is thinking about and tendering the extension of this project now with our dry cooling. So thank you very much for your interest. Thank you.
Tak děkujeme za tu prezentaci. Myslím si, že je skvělé
Thank
mít
you
tady
for the
zástupce
I think it's great to have a representative of a neighboring country or a very close country in the Central European context, particularly a company that has the ambition to be part of the nuclear redevelopment and building new nuclear sources in Europe. So thank you for that. By the way, we have the competence center, the only and the biggest nuclear competence center supported by the Technological Agency of the Czech Republic. So you can see the promotion here. And it's a corporation that produces great technologies. We'll be talking about them later. There are three topics we'd like to cover in this panel. Innovation is one, industrial cooperation is another, and competences and the rest of it will be our number three. So let's start with the first one, the first subsection, whatever we call it, and it will be innovation and advanced technologies. I've already touched upon what we could imagine under this. I think there are three different subsections that we can actually think about. The current operations, the current sites, such as the Dukovany nuclear power plant has been in operation for 40 years now, and you know that it's been upgraded and improved. Technologies have been used, such as reducing the conservatism thanks to better computational power, speeding up the operating controls, exchanging the heat exchangers, etc., etc. Our colleagues will be talking about this. Abacam, obviously. Then EU resources, I believe, is another area we can talk, kind of overlapping with the current units. And the last area, the way I think about it, would be the fourth generation reactor. So, gentlemen, I'd like to invite you to start based on your personal experience and qualification, because you're very experienced. I'd like to invite you to take a look at what innovations you see as the biggest movers in this technology in the next 10 to 15 years. Who wants to start?
Tak zmiňoval jste tady
to zvyšování výkonu. You mentioned things like improving the operations and controls and also increasing the output, etc. So at SCADA-JS, we were involved in this upgrade and refurbishment of the Dukovany power plant, a big project. It took about 16 years. And so both the safety or safety-related or non-safety-related systems were improved. It's about the added value, speed, accuracy. It's about data processing. It's about visualization. All of these have gone up in their standards. And we've completed this upgrade, and we are already preparing the next one, because the first one has been in operation for 20 years now. As regards the 3+ generations with the light water reactors currently in place represent, we are dealing with the innovation, and we are improving our diagnostics. We are implementing model technique which is mathematical support, verification and validation of software tools. And there's a whole lot of other tools to improve and increase safety and to enhance the control systems. As regards the 4+ generation, what comes into mind is AI, digital twins, and that sort of thing. All of these things will have been reflected gradually over time in the next generation, the 4+ generation that will come in 15 years, maybe later from now. Okay, what about Skoda JS? Yes, I'll be very happy to follow up on this. And I do subscribe to what the gentleman before me spoke about. This is a fairly broad topic, but it's true to say that Dukovany is now celebrating the 40th anniversary together with Bromatom and together with our colleagues. We refreshed, renewed the safety systems. That's great forte, I suppose. But we are moving on. We're going forward. We work at Metsamor in Armenia. The old Soviet design was used, and we had a great period of cooperation where we ran the reactor control system. Now we are following up on this, and we are now improving the safety, nuclear safety, in terms of the limiting system and in terms of the reactor output control system. It's now in the detailed design stage, and it should be implemented next year. So, based on our previous collaboration and great references, we are building jointly again further business cooperation projects and improving nuclear safety. Currently, the safety and regular operation systems at Temelin is being delivered. And it's been 20 years in the making. Time is really flying, and also certain systems need to be renewed or upgraded. And it's been, I think, 7 or 8 years that we did the last project in that. It was outside the reactor. And we are now revamping a very old analogous system into a digital one that will allow you to control and monitor 8 different units one at the same time. AI and this sort of thing, I think it's fair to say that I fully agree with the idea that this is the industry for the 4th industrial revolution in the making, and I know only a small fraction of what this can do. I mean, the large language models just in their own right can become a technical partner for a discussion. For instance, I no longer remember Russian, whenever we probably learned it. The Metsamor Armenian site obviously has all the documentation in Russian. So you can communicate with the model, large language model, and it sort of appears to be speaking Czech. You know, a guy down there in Armenia who speaks Czech. I mean, yes, you need to use critical thinking even more now than ever, I'd say. I think that's something that the institution education facilities should definitely take into account, because sometimes it can be really hallucinating. But the large language models can be really helpful, and yet they consider to be just a small fragment of what AI could do. If you think about smart operating procedures, maybe analytical methods and that kind of thing, that our colleagues are using. Okay, that's it from me by way of introduction. Let me ask you one more question. This is perhaps to Karol Spotřes. You mentioned the upgrading of SKRs at Dukovany. And what do you think about this? I mean, is that perhaps counterproductive? I mean, my feeling is that sometimes the more sophisticated the systems are, the shorter their lifespan is. You know that availability of replacement parts, and today it's called obsolescence program, that seems to be really difficult. So what do you think about this system?
Well, again, depends on the scope and the configuration. So what we want from the control system. So from the perspective of the digital systems, for 15 and 20 years, that is not a problem. So the life cycle can be that long. Of course, there are certain elements in the upper layer monitoring or HMR, which is based on computational systems. So of course, it doesn't have such a long life cycle because it has to be running 24/7. So the life cycle isn't as long as the PLCs, for example. So you have to renew it more often. And we did an upgrade in Dukovany once already, so we replaced all the computers. So the life cycle is maybe half of what I've mentioned, half of the 20 years of the low-level control systems. Okay, but in terms of benefits, yes, of course, it has its benefits. The computers, of course, you would have a different computer in your office, and as an industrial solution, it needs a different level of cooling and other components. So yes, of course, the industrial computer would have all the latest developments, latest components, but still it has limited life cycle. Mr. Ondračka, you have 7 companies in your group, so you can choose. So where do you see the biggest innovations in the horizon of 10, 15 years to come? Well, of course, AI, that's number one innovation. Whether we use it for training models, or for analytical models, or data collection, data analysis, or predictive models. There are all sorts of opportunities for using AI. So that's a huge advantage. And since we're also active in research and development, sometimes we look too much ahead in time. And we also look at different types of reactors, that is SMRs, or the liquid salts, and related fuel cycles, or a potential reuse and recycling of fuel cells. All of these are interesting topics for us. But we deal mainly with waste management. But in waste management, you also have many challenges. We have a joint project called Canut, where we try to address all these challenges. So when some nuclear operations, nuclear installations will be decommissioned, we will have to deal with the nuclear waste. So we have waste management legislation that we have to adhere to, and that will change. There are certain exceptions for nuclear waste, so we're trying to foresee what will happen, and we try to develop new methods, new processes to deal with that specialized waste. It is not as easy as with standard waste, because with nuclear waste, you have that added radioactive material, and there are many new challenges in front of us, whether we speak about solid or liquid waste. Mr. Jakubek, I think you've already mentioned on your slide what your company thinks about innovations, but what do you think is ahead of you in your field of activity. Well, my field overlaps with all sorts of other fields, like new materials. Of course, new developed materials should have longer life cycle. It should be more resilient, against corrosion or radiation. And our methods make it possible to monitor the surface of the materials and identify even micro cracks during standard operation. So corrosion under insulation, that's one problem. So if you have a steel pipe, for example, which is coated with thermal insulation, but between that thermal insulation and that steel, there might be some processes going on over time, and it might disrupt the surface of that piping, and you have to monitor that. And of course, in nuclear installations, often you cannot do it without a shutdown. We have methods that we've developed that allow you to monitor the whole piping and see whether there are any cracks or any changes or any cavities, simply any disruption of the integrity of the material. And you can do that during standard operation of the plant. You can also monitor welds in the same way. The standard methods are based on radiographic coating, and when you're welding, you want to monitor the welds, the quality of the welds. And if you have a team of 2 people, they can check maybe 8 welds, 8 welding points during one shift. So if you use our method, it is much faster. You can do much more work. They can manage the same volume of work within 1 hour rather than one shift. So the technological shutdown is shorter, and you get a digital print of the current situation of the weld, and you can compare it with digital images of that weld in time and see whether there are any degradation. We also measure radioactive fields, and we talked about a fuel cycle. So it's a whole chain of technologies, from preparing the fuel, then handling the fuel, after its processing. So you have to deal with integrity of the fuel cells, you have to deal with storage, and you need sensors for all of that. And our sensors are unique because they can see every single particle of the ionizing radiation, and we see the type of radiation, the wavelength, and all the other things. So we can, in most cases, identify the source of that radiation. So we know the type of radiation, the source, and we can also identify the features of that radiation field, the intensity or the composition. And our sensors are roughly this big. So this is the size, and you can have 10 of them. We have 10 such sensors, for example, in the ISS. So we have applications in space as well. So when you do measurements and analyze data, and you use our sensors, you can connect it over USB. We also have a wireless solution. So that's where I see our future. So monitoring during standard operation and developing new materials. Well, I thought that maybe you could show the sensor to all of us, but maybe it wouldn't be returned. But this is just a mock-up, a rubber sensor. It doesn't work. So I talked about increasing computational power that we will need in future. How far can that go? What do you think? Well, that's a good question. I was hoping that you change your question, because in our field, we don't even know what will happen in 2 years, not speaking about 8 or 10 years or 15 years. The simulations that we run work on equations that had been discovered before the war. So you can apply standard physics. And once I talked to my brother, and we talked about what we do, and in the past we worked on cars and developing cars, but everything has been developed. And my brother is a trade director, sales director, so he doesn't really understand much of the technical field. And I told him, well, the car 20 years ago had half the power, double consumption. It was much heavier than today. If you compare it to the car today, it looks similar, but of course it is different. The power is bigger, and with higher power, you can do much more. And the same applies to computations. We can do things faster to a larger scale. We can simulate, and we run simulations basically for every nut and bolt that we use in our installations.
There were some major leaps forward, for instance, graphic cards. All of these computations are pretty simple in terms of the formulas used. But if it's in huge numbers, then the universal processor is unnecessarily big for it. So at that time, they thought, well, okay, we will use more processors and increase the frequency. But for instance, the graphic card processor can do it for handling thousands of tasks running in parallel. Look at NVIDIA, for instance, as a company. And this kind of computation task is now handled with such ease. And I can imagine that within 10, 15 years, maybe later, quantum computers will be involved. The development stage is really promising. We see a lot of promises with a lot of promises. It can come in 10 or 15 years from now. The next thing that was mentioned earlier was artificial intelligence. Some people say it's a bubble, other people use it on a daily basis. But we see already in our field that you can do things that were not possible last year. An engineer who's never programmed, never coded, can really use a profile to say, okay, I need C# or I need a Python program, and it can simply do it for him. We are dealing with AI projects. We are handling AI projects, and people with visions in this field say that this technology will allow people to do things that have never been even thought of, ever conceived, or not yet to be tried. Maybe people will be fearing, maybe people will be just testing the ground and see how it works for them. So when I talk to people about AI, some people say, well, it's going to be the bubble, it will just burst. If you do have these tools, you can get outputs at the level of simulation outputs at a level that has just graduated, let's say, with C's, okay? If it's someone who can do it, really, who knows how to prompt the system, then it can be at the level of someone who's graduated with straight A's, for instance. And it will be also for 4 people, working for 4 people instead of just 1. If that engineer is stupid, then you can have 10 tools and you will get stupid outcomes, of course. That will not change. Okay, thank you for that. Mr. Takáč, you mentioned your cooling systems, and we know that at Dukovany it was one of the major limitations in terms of how the units would be big because the cooling capacity would not be sufficient. I know that every 10th of improvement in the cooling in the water cooling system has a major impact on the efficiency. What can we think about as the next big thing in your area?
You are very right. The cooling system belongs to the balance of plant part of a power station. In a nuclear power station, because of the low steam parameters, live steam parameters, relatively large medium flows arrive to the condenser, and the turbine back pressure is an important factor for the overall efficiency of the plant. So we have to keep it in mind, but there are other factors, environment compatibility, water saving, whatever. And the drive solution, what we consider here, looks like one tower can serve one unit. So regarding the arrangement, this is in line with the project available area. These are large cooling towers, around 180 meter tall, even bit higher. This is not the largest one. What we have, we already implemented 223 meter high tower elsewhere. So this is not the top category. And in the drive tower, we have to consider that well-known technologies, the dry cooling separately, the wet cooling separately, are combined. They have to be combined in terms of heat and mass transfer, in water and airside hydraulics, and for this successful combination, we use CFD modeling. We have our in-house CFD modeling capabilities. We have our own laboratory where we measure the heat exchangers, or we can measure also other products like wet cooling fields. And we have to combine these puzzles to a successful solution where both the financial operation is successful, both the technical result is successful. Of course, safety and reliability are key issues as well.
Děkujeme.
Thank you.
Teď je ta chvíle, kdy má prostor publikum.
Now is the time to turn to our audience so that we can bring this panel, this part of the panel, innovation, to a close. I believe there's lots of innovators in the auditorium. But I don't see any hands up. Never mind. I'd like to stop for a bit at artificial intelligence. We can talk about it for hours. You mentioned data processing and programming. Fair enough, I can imagine that. But how far can we go with AI in terms of control systems or maintenance? Well, this is a nuclear facility, you know, this is a nuclear power plant, so we can be very cautious there. However, we plan to use AI in the system of requirement handling. So that's for the next stages of engineering. So I'm sure that there will be points or places, areas in the supply planning system where this will be used, and it is being actually used already. Okay, can I just ask Mr. Kuchanek over there, that if you can imagine that the AI-driven based tool would be actually operating in the control room? ČEZ, the operator, is already using AI for things that have been already mentioned, such as analysis, design, etc., etc. And we, the regulator, are also about to deploy AI. We already use it, but we don't use it for sophisticated use. I mean, we are working towards it, so that we can use it for assessment, etc., etc. And even the European Commission is not lagging behind. Several grant projects that were launched last year, and the European Commission called for a dedicated solution, AI-based solution for regulators and inspectors. It would be able to work with a relatively safe system. I think the biggest threat there potentially is that data would be actually dispersed. So we are
Děkujeme za
making
tu vsuvku.
huge leaps
Tady se
forward,
hlásí ještě pánové
and
z
I
oddělení.
see this in a very optimistic manner. You want to do that something, right?
Už je záno. Jenom jestli můžu doplnit naprostý
Okay, if I can add thought contribution, I absolutely agree. And the control systems in power plants are deterministic, meaning you have this major philosophical foundation stones, in fact, of being a deterministic system. So clear input, clear output at any given moment in time. Once we have AI safely proven that it can really control these systems with this deterministic approach, then okay. But I can already see a potential that you can, the average run-of-the-mill type of activities and that are even slightly creative perhaps can be replaced, and then this smart engineer can work more efficiently and can actually handle more. So I believe that the cost of human labor obviously is important. So this is the main criteria in my book.
So, gentlemen, you wanted to add something to it? Well, yes, controlling systems in nuclear power plants is deterministic, but aging of materials and various cracks and corrosion, that is not easy to determine. It just happens. And we have a project for medical applications, radiograms and images. In the industrial solutions, we still have to stick to standards. So if we have an image about on the image you have a weld, and we still have a human being using his or her eyes, looking at that image and trying to identify cracks. And it depends on the condition of the person. He might be tired. He might miss some of the cracks. So it could be possible to train an AI model that looks at that image and maybe recommends something or points out something to the human being, to the technician, and says, look at this. This is something that was a mistake or a potential mistake last time. So look at it. Maybe it's a mistake this time as well. So today, the technicians look at an image at a specific time, while we're developing methods that will be able to monitor on a time scale the development of a given location. So I can identify something that is suspicious. If I see an image which hasn't changed for many years, then it's okay. If I see a certain change, or the AI model sees a certain change, it might be pointed out to a human being to look at it. Because there's something that's changing and it shouldn't be changing. So AI could help with pointing out these potential problems. Yes, we're looking at the potential usage of AI as well. For example, if you have loads of data from sensors, there's a lot of dim noise, and it is difficult for a person to orientate himself in it. So if you have a neural network, it is easier to handle it. And in our team, we always have a lawyer or a law firm, because we are technicians. We can set up the system very well. And if it collects data and analyzes data, fine. But then somebody might have a look at it from a legal perspective. What kind of data are you working with? Did you put it somewhere up on the internet? It might have leaked. Maybe it's in the US already somewhere. So what I'm saying is that we do not have skills in all the fields, and we definitely need to have lawyers in our team as well. Okay, a question from the audience. Ondřej Novák from the Czech Technical University in Prague. So when I was in Korea a few years ago, I think it was in KHNP, and they showed to me that they had a flow of data from one center or into one center from various power plants, power facilities, from various components in the power plants. And I've used some kind of AI models for continuous monitoring of the state of affairs, of the condition. And they tried to use it to predict the need for maintenance and repairs and predict a potential breakdown of that facility. So do you have any experience with the usage of AI for such a purpose in the Czech Republic? Are we doing this as well? Well, no, I don't have such an experience. I know it is possible. What I would say is that you have to be really careful about this. You can have such systems working offline, and you have to monitor the development of the system from the very onset, because it can be too open and data can leak somewhere you don't want it to leak. It's a question of protecting your system and your data. Was there any other question in the audience? If not, let's move on, gentlemen, to industrial applications. Of course, logically, we always have discussions about the engagement of the Czech industry in the building of new nuclear sources, whether it will be 50% or 60 or more. But it's a pity we don't discuss more the involvement of Czech industry in maintenance. In Dukovany, the cost of modernization and maintenance amounts to some 3 billion Czech crowns a year. And with the new unit, it will be quite similar. I'm sure there will have to be maintenance and modernization done. If the units run for 60 years, a non-discounted value would be 60 billion. So it's almost the same amount of money as you would pay for a new unit. And we're talking about the involvement of Czech industries only in the construction stage, but there will be a long period of maintenance and repairs. So how do you see the potential involvement of Czech companies once the new units are up and running and they just need continuous maintenance? So what's your ambition in that? Well, yes, we're doing our best. Of course, if I want to do servicing and maintenance, I have to be there from the start. I have to learn to work with that technology and ideally be the supplier of the control system, because then I would have the know-how for the maintenance later on. So the more I'll be involved in the whole process from the onset, the more I will be, or I will have opportunities to do maintenance. So it is about being involved from the very start. So be there when they're designing basic design, retail design. So be there throughout the whole engineering design process. Be there as part of the delivery, and then logically you will be involved in the maintenance. Yes, I think there will be many cases when the Czech companies will not be involved in the delivery at the beginning, but they will have an ambition to do the maintenance. Well, logically, you have to know the systems if you want to maintain them. So if you are not there from the very start, you have to learn it, and somebody has to teach you that system. And of course, our ambition is to be there during the delivery. Well, if I may comment on that, this is a typical case of digital twin. It can be used in research, but it definitely can be used during standard operation. You can build your digital twin, all of you. You have your engineering teams. There's a company manufacturing pumps represented in this room. They're active around the world. They have hundreds of pumps installed around the world, and they have digital twins that provide information about the operations of the pumps. And if there's any problem with the pump, the digital twin informs the team what the problem is, what needs to be repaired or replaced, and they take the spare part with them already. In the past, the team went to the site, discovered, they had to find out what the problem is, then they flew back home for the specific part, and then back to the site to fix it. So digital twin could be a good solution. What about Škoda? What do you think about maintenance?
I think it's clear that nuclear power plants uses a defined periodic maintenance service and as defined in the project, and obviously that can't be done without human intervention. And I haven't really seen this in the debates so far. You know, the people have been talking about things like Rolls-Royce getting maintenance into maintenance issues and things like that. And Rolls-Royce obviously is doing a good job. It looks promising with the help of the Czech mother company. I think this is the key thing. Then the key issue is how the future operators want to go about doing maintenance and service. It's usually outsourced these days. The nuclear island or some other companies, but that's the concept used today. I'm not sure about the future, and this may be a question you'd like to ask to the future operator. They might want to have these capabilities within the group, right on site. So it's a good question, but I don't think you can get an answer now.
Jsem přesto rád, že to tady docela důrazně zaznělo, že prostě pro budoucí efektivitu údržby je klíčový, aby ten český průmysl
for the future effectiveness of maintenance, it's key that industry is involved. So that would be another case argument for the involvement of Czech industry. It's good that we mentioned this. Okay, talking about maintenance, Mr. Ondrečka, can you please outline the ambition of the unit center? What is it good for? The idea is that it will put together about 5 big buildings or even 5 compounds. Part of them will be administrative buildings, delivering services, contributing to the process of managing the site construction and after the construction. Other spaces would be reserved for measurements, analysis, specific analysis, and then also places to be rented to whatever operations might be going on on the site, such as storage, etc., etc. So we are growing in terms of the number of companies involved. It's now several places and several spaces that will be kept for the group's own companies. The others are sort of preliminary contracted, but there is still space open that can be rented out and used for other companies. So this is where we're heading. Okay, thank you. Mr. Zalba mentions Rolls-Royce. I personally don't know if there's going to be any major difference between maintenance and innovation, SMRs, and the big reactor, the reactors. I don't know if there will be any difference there, but I think it's still specific in terms of the contractual arrangements when you talk about SMRs on one hand and the heat reactors. So is there anything that is specific that we should keep in mind in terms of supplying these 2 different concepts? I can only talk about the control systems. I wouldn't dare tread on other soil. But if you look at the documents, if you look at the documents that are publicly available and are part of the GDR process, then I have to say that it's very nice to see that our colleagues from Rolls-Royce are trying to look at the existing technology through a different lens and try to find new solutions, although not at the expense of safety levels. If you look at the INC architecture, it's way more straightforward, but the main functions, the main ideas there are still present. So I see a major and certainly successful effort to arrive at a more effective and better solution than we have today, because that is also based on the experience we've landed so far on the existing unit. And I'd like to add that modularity is a big challenge. It's sort of understood that it will be simply brought to the site and then interconnected in containers. So in terms of the control systems, modularity is also a thing that we need to handle, and we are trying to prepare for it so that we are modular also in the control systems area, so that we can adapt to the needs. And this is also obviously dictated by the safety analyses, because that will dictate the control system architecture. It can be usually simpler than for SMRs compared to big reactors. Some of these things will be the same. Okay, let's turn the tables to our audience. Anybody in the auditorium has any question on the ideas we developed here? Okay, in that case, I'd like to come back to the issue of modularity. It's like Yeti, you know, the mountain creature nobody's ever seen. Rolls-Royce is said to base their efforts on the modular system that is usually applied in airplane engines, but I simply think about it as Feral Stoches. I imagine that there will be several containers to be brought to the site, and then using bayonet-type connections, we would be just linking this up to the utilities, but that's probably not the case. So what would be the biggest limitations in terms of modularity? I suppose control systems were pretty easy. That also has all systems, all control systems modular, but what do you think about this? So to what extent is the modularity of the buzzwords really achievable? To what extent is it realistic or non-realistic? Okay, I seem to have hit the nail on the head by asking this question. Well, as you said, I mean, nobody's ever seen it. So it's difficult to say. In principle, well, let me put it this way. It's 470 megawatts. That's the that's essentially the unit, the one unit of the Plenary. So it's not that small. So it's about the level or measure of modularity that you can apply there. So it is now being created. So okay, modularity, yes, but we haven't seen it yet. I personally don't consider it a total fictitious idea. No, this is not science fiction. Modularity on the level of cabling, probably not. That would be a typical example. What about cabling? Yeah. What I heard or what I've read about it is that cabling is not to be disconnected, and then simply we will put the modules together and then it will be simply woven through the cabling. Oh, okay, fair enough. I can imagine it, kind of. In terms of the systemic distribution and division between individual rooms, that's fine. That seems pretty realistic. But there's one thing that I can't really assess. other experts will have to step in, and that is the reliability and protection levels, chemical substances between the different spaces and rooms, partitions, etc., etc. So these are the questions that our colleagues from Rolls-Royce will have yet to answer. So I can see certain concerns there. So control systems and power systems, power supply systems, yeah, there might be solutions. And an exchange station just came to my mind when we were electrifying our vehicles, switching to e-cars. It just built the charging stations everywhere. The current exchange stations were not up to it in terms of capacity. So a company just brought about a container. They installed one container, plugged it in, and that was it. So yeah, I think this is a good idea as well. And any good new idea might have its challenges, but if we run into challenges and problems, we have smart people to solve them. Well, I guess our debate proves that even in the Czech Republic, we should be maybe more active in research and development. Maybe just a short comment. We're focusing mainly on the peripheries rather than the core of the technology. And I am a bit concerned that we might have a problem with modularity. For example, when it comes to wastewater and processing of the wastewater. So for the SMRs, the model would probably be based around a logistical solution, and that will be tailor-made for a specific location. So wastewater and other waste material, it will be about collecting the material, transporting them to a central treatment plant, and that's related to certain risks. And it also means higher costs, transportation, to be able to process all types of waste coming from these nuclear facilities. Any more questions or comments on modularity? Okay, we don't have to dwell on it. I would want to use the presence of smaller companies and ask you guys, how do you see cooperation with larger companies on various projects, be it new nuclear facilities or potentially working together with the big guys on SMRs? Well, as I've said already, we're all members of that one project, SANUP 2, and it works very well. We have a number of projects with the research center in Rzesz. We used our sensors to detect cracks in the material due to aging. And we monitor, thanks to our sensors, not just materials on the peripheries, but also on the overall installation of the nuclear facility. Well, maintenance. When do you want to do maintenance? Usually we do maintenance when something breaks down, but in a nuclear power plant, you cannot afford to wait for things to break down. You have to think ahead. And now the question is, how do you do it? How do you go about it? I mean, do you test the pipe? How much force you can apply before it cracks? But you find the limit only when it cracks. So you have to be predictive and develop new methods to forecast the life cycle. So, of course, the life cycle of nuclear installations is so long that the methods that we're only testing today will be quite common in the future. And I talked about various ways to
test the surface of various materials, the cracks and bubbles. And thanks to our sensors, we're able to identify a potential future problem. For example, increasing tension in a material, be it due to aging, due to disruption caused by radiation, because of some reactions or corrosive environment. We're able to monitor the changes of the material and to monitor, for example, internal tension of the material. And once it exceeds a certain limit, we will replace the pipe. We don't have to wait for the design life cycle. And the pipe might have a life cycle of a certain number of years, but you're scared that it will break. So sometimes, just in case, you replace it too early. And if you use our sensors to monitor the condition of the material, you don't have to replace it so often, and you can save costs. Innovations are coming and going so fast that maybe in a few years' time, our perspective will be again very different. Maybe just a few words. We're a small company, but we cooperate with large companies on an everyday basis. And it's a smooth cooperation. Of course, we can envy the large companies, their possibilities, their budgets, but they envy us, our flexibility and fast decision-making. So, yes, cooperation with the large guys can be great and a huge advantage. And of course, cooperating with universities is also excellent because they're full of smart guys and girls. They have their labs, they have other possibilities. But of course, their decision-making is limited, and also there are summer breaks and so forth. But if you combine the big guys, the small guys, and universities, you can put together an ideal team. Well, yes, that's what I actually wanted to get to, because we are at a university at this moment. So let's close the panel with universities. Somebody mentioned that even if you're not skilled as a programmer, you can use various tools like AI to program things that you need. So what are the possibilities to use these various tools in those large projects that are ahead of us? Just very briefly. Via Alta, our company, well, actually, it was renamed to Vades. We have many projects, research and development projects, where we cooperate with universities and also industrial partners. And cooperation is hugely important for us. It's very beneficial. We have a large scope of various activities, and of course, we cannot have labs for everything, every single type of measurements and processing. So cooperation with those partners that have that is key for us. Cooperating with universities of that kind, that we support them and they give us, or they respond with sending students over to our company, for example, for some practical experience, or they can participate in research projects. Well, it is easy to find a dull engineer, but to find a highly qualified, skilled and smart person who can work independently, it is much harder. So in research and development, it can't pay enough to have really skilled people, smart people. So cooperation is key. Well, maybe we can ask the universities what they think about it. There are many people coming to us asking for work, and we sometimes send them over to our partners. And companies keep complaining that people don't have the skills, but they can be trained. What we rather lack in the new or fresh graduates is that they don't have the habits, the working habits, those that you need for a standard working life. So, of course, we want to train as many experts as possible. We need them. But sometimes we're off balance with what we offer and what we get. So the graduates, if they have the skills, if they have the knowledge, that's enough for us, and we can teach them the rest. Okay, anything else you want to add, guys, when it comes to skills and competencies and knowledge and what's needed? Okay, audience, do you have any questions?
Hello, Jana Jiřičková. It's great that you mentioned this, Mr. Popovic, and I'd like to use this opportunity to invite you to our session in the morning. It will be focusing on training young people in the energy sector. And we can clarify what the needs are in terms of you, the industry, and us, the people. So I hope to see you here on at 9 o'clock there. Thank you, Jana, for bringing this to a nice close. I can see one hand up here. Hello, I'm Duda from the University of West Bohemia. I wanted to ask a question. When we talk about industry here, you seem to be looking at the fissile, the fission style of really nuclear technology back to Fermi and the Manhattan Project. But how do you view fusion, the opposite side of the physics? So are you trying to contribute to the development? We don't want this to be a constant after 30 years, is that because I've said? I think this is a great question, but I'm not sure I can answer it in 5 minutes. Well, definitely, Advacam will be thinking that, would be expecting that their sensors would be used in fusion applications. I don't know about our other giants of the industry. I don't want to really put you off, but maybe that'll be a great topic for the next year of this conference. I don't know if you heard about it. You maybe heard about the ambition of the chairman of the Academy of Sciences. He would want to build a fusion site by 2040 in the Czech Republic. Then we can get involved. But I agree that this may be a premature question. But okay, maybe next year for this conference, but perhaps it will be a bit for the next but one. Yeah. I do apologize, Milan Štekl from the Czech Technical University. Just want to follow up on what you said on the students. UC London, which is the number 10 in the world, every single doctoral student needs to go spend 1 year in a private company, and they have to do it. It's mandatory. If you could organize this, we would welcome this. If I can add one thing, it's an interesting topic. I do apologize for chipping in. Teaching practice at a university is sort of different because it's not professional teachers who teach here. It's doctoral students who then later teach, and they don't know how to teach. They will simply distribute a test, they will administer a test. Either the student is able to say U235, if he add a neutron, it does this or does that. But they are not really able, I mean, the first students who are teaching here are not able to test the technical knowledge, whether the student is really understanding the basics. So this is a fairly interesting point, which I'd love to bring up, and you should be developing it. It's great that you're mentioning this, because someone mentioned that the Czech-Korean Center of Collaboration or Excellence was opened yesterday. I think we have a lot to learn from our colleagues from King's, because all the people there are professors who have gone through KEPCO one way or the other. So cooperating with KHNP or KEPCO or King's will certainly give us an opportunity to learn something from
Tak poslední,
what they
poslední
do
závěr,
in this area.
Jste mi krásně přihrál, že jo, protože my tady tu verzi toho
Yeah,
detektoru
this
právě
is a
schválně
great
dáváme. A to je
um,
přesně vtipný, protože studenti se samozřejmě
great
přesně učí
example of
elektronikne tamhle do úrazu, co
collaboration.
se stane,
You said
ale kdyby to
exactly.
nevěděli, jak to
It's
vidět, že jo,
U2,
a ten to vidí, že jo, takže jsme si tady to
235,
necháte zapnutý na stole a
and you
vidíte,
add
jak
1
tam přijítá
Newton,
myon,
and
občas narazí
you
do toho
see what
jádra a
happens,
posune
but
ho.
you are
A je
not
to vidět
able
na
to see it.
obrázku,
Okay, this is what the
takže
students get to
studenti
learn, but they
takhle
can't
stačí to
see it.
rozklepat, je tam
So
vidět,
this is
že to
great.
vypadá, jak
Well,
jsou
we
alfa
can do
částice
it.
z toho radonu.
You
Dá si
see,
to ke kusu prostě
if
nějakýho,
you have a sensor,
nějaký
you
švůl
can use the
jazyky,
alpha
snad to něco
particles,
udělat.
and you
To
add
je přesně ono,
granite, and
hands
you can
on,
see, okay,
jo,
this is
vidět to.
what you
Jenom
get
se
to see.
soustředit,
Putting your hands on
matematika jenom
means
jazyk.
you get
Když
it. I
nemám
mean,
co říct, tak je
mathematics
zbytečná, jo.
is just a language, but you
Takže
have nothing to
zakončíme
say,
tímhle
it's
optimistickým
useless.
konstatováním. Jsme
Okay,
neuvěřitelně
sounds pretty
přesní,
optimistic. I guess I think we're
organizátoři nás
terribly
pochválí.
accurate.
Já
The
bych vám chtěl
organizers
všem
will
moc
be
poděkovat za
praising
to, že
us.
jste
I want to
vydrželi do
thank you
pozdních
all very
večerních
much
hodin.
for staying
Chtěl
with
bych
us
moc
until this
poděkovat
late
všem
hour.
našim
I
panelistům za
want to
velmi
thank
zajímavou
all our panelists
diskuzi. Myslím, že si
for this
zaslouží
very
potlesk.
interesting discussion. Please give them a big hand.
A nezbývá, než předat slovo panu
And
Zdeborovi.
I'd like to hand over to Mr. Zdebor.
Tak já samozřejmě budu také děkovat.
I'll be thanking too. First of all,
Kteří se účastnili tohoto
I want to
kulatého
thank
stolu,
all
také
our panelists
moderátorovi.
as well as the
Snaha
host.
byla to dostat někam, kam se to
We
zatím nedá, ale
We're
ale
trying
takže díky i za ty
to
za tu
get
snahu.
our discussions to
Samozřejmě to, co už říkal
somewhere
kolega
where
poslouchal,
we simply can't get
za
so
některé
far as
doktorandy,
yet.
to určitě je
But
pravda, ale oni na té škole
going in the
učí
right
jenom
direction.
doktorandi, takže
And what you
oni
said
to
about the
tak,
doctoral
tak,
students teaching at the
špatně, jak
university,
on to
correct,
nastínil, ale
but
je to
we
důležitý
don't have
to
just
říkat
doctoral
samozřejmě.
students who are
Takže
teaching
já
there,
bych
but it's
vám
important
všem
that he
rád
mentioned it.
poděkoval ještě jednou za to, že jste
Let
vydrželi
me
až doteď.
thank you once
Já jsem
again
moc
for
rád,
staying
že
with us
jste
until
tady
this
byli
late hour.
vyprázdněni, protože to byl velmi zajímavý
Glad
panel, ale
that
hlavně tady byli lidé z
you
konkrétních
stayed,
firm, takže
because it was a
proto
fairly
jsem si
interesting
myslel, že
panel,
bude
and
ta
I'm
diskuze
pleased to know
zuřivější,
that we had the
ale byla
pleasure of
velmi
having people
jako
representing various companies. It was a very lively
byla fajn,
debate.
ale zítra
I
pokračujeme,
even thought it would be almost
pokračujeme docela
as live as close to Curious,
zajímavými kulatými
but
stoly,
never
jak
mind.
jste
It was
se
good, and
podívali
we'll be
do
continuing
programu.
tomorrow.
Takže teď mi
I'm
nezbývá
sure we'll
nic
see the
jiného, než
agenda for
poděkovat
tomorrow. So
ještě
once again,
jednou všem účastníkům kulatého
we
stolu,
appreciate
všem účastníkům
having you here.
Plenary, pozvat vás
I
všechny na
appreciate
dnešní společenský
all
večer do
the
Prazdroje, to Plzni
visitors
patří a
and
myslím si,
participants.
že se na to
You're
těšíte.
cordially
stejně jako já.
welcome to the Pilsen Oakwell
Takže
premises
ještě
for a
jednou
social
děkuji
evening.
za dnešní den. Vám tedy poděkuji ještě
So thank you once
tím, jak
again
děkujeme všem
for
účinkujícím. To
this
znamená,
day,
dostanete
and you'll be
nejenom
given not just
poděkování, ale také
this
vzorek
thanking,
medu
but
od
you'll
našich
also get
včel,
a
které
sample
sítí tady na
of the
sousední
honey
budově
produced by the
nahoře
bees
a už se to stalo tradicí.
who have
Takže
their site,
díky ještě jednou.
their production site or beehive up on the roof of the neighboring building. So I'll just walk around
I vám,
the
pane
table
Stečesi.
here. Thank you, Mr. Stachel, as well.
Díky moc. Med vás čeká. Děkujeme.
Thanks a lot. The
Thank you
honey
very much.
is here for you.
Specially for you.
Thank you very much.
Special honey. Tak děkuji ještě jednou a těším se s vámi za
Thank you once again,
hodinu
and I'll see you
na
in
společenském večeru.
1 hour time from now at Pilsen at 12 for a social evening. Thank you.
Ten první festival, on tam se došel z mikrofonu a byl slyšet celý sál. Ještě musím Už jsem mi dál, respektive vlastně vezmu ještě vedle. Ten bazmek.